VMware back in 2014. Now he runs Altinity, that happens to be like your 20th database.
20th database.
But he lost count, because now he's an expert and he has more
Right.
than 3+ decades of experience of database management. So he's going to be presenting a talk title, which is the lessons from ClickHouse Operator. So the room is all yours.
Great.
Yeah.
Thank you very much. Do we have audio? Is it working?
This is just for recording.
Oh, okay. It's just for recording. Okay, great. I'll speak loud. And this is thank you so much for coming. I know this is kind of late in the afternoon and not everybody knows this technology well. I'm going to dive in. I have a little teeny demo to do. If we get stuck for time, we may skip over it. And whoops. Okay. All right. So you just heard about me. Yeah, so ClickHouse is database number 20. Altinity is startup number 6. I kind of like little companies. So what we do in Altinity is we provide software and services for the ClickHouse Data Warehouse. And I'll talk a little bit about that because that's the data warehouse we experimented on as we were learning about Kubernetes, and it's the one that we work with every day. So the role of the company is basically to make this data warehouse, it's open source, make it safe for enterprises to use. It's actually pretty easy to run, but we do the things that make your managers happy to use it. For example, providing 24/7 support, fixing bugs, all that sort of stuff. So we're a major committer and a sponsor in the U.S. and of the community in U.S. and Western Europe. Let's just dive in. And I have a starting question for this talk, which is how many people in the room actually use Kubernetes right now? Okay. This is actually good. I just want to, because I have an introduction. So without defining any terms, I just want to talk about some general questions that I'm going to be addressing. It's like, why would you run data on Kubernetes? Well, in a minute, I'll define what Kubernetes is so that question will make more sense. But there's actually some pretty strong reasons why this environment is important. First of all, a lot of people are using it for their apps. And for reasons that I think you'll see as we go along. It's basically a way of running containers. So we'll show that in a minute. It's very portable, so you can run on everything from this laptop, down, all the way up to services on Amazon. It's very fast to deploy complex applications, particularly complex applications that have a lot of pieces. And it has a very flexible mapping to resources. And this is not a big deal when you're just developing on a laptop or sort of doing something, sort of in a development or testing mode, but it becomes extremely important when you're running systems at scale to be able to use hardware and other resources efficiently. So let me give a really short introduction to the ClickHouse Data Warehouse, since I assume, has anybody in this room ever heard of ClickHouse? Okay. Normally we have a T-shirt and we throw it at you, but I couldn't bring any. We ran out. So let me give you a little bit of an introduction. How many people here have heard of MySQL? All right, pretty good crowd. How many people have heard of Vertica? Well, that's pretty good too. Okay, so Vertica is a pretty well-known. So MySQL, famous open source database site, drives millions of websites across the world. Vertica is a very famous column store. So imagine that MySQL and Vertica got married and they had a baby. Well, this baby would be ClickHouse. So MySQL is super portable. So ClickHouse basically runs on bare metal to cloud. It's open source. That's MySQL. It's easy to run. ClickHouse is also very easy to run. It's just a single process. You start it and you're off and running. And then it also shares some important things with Vertica. It's a column store. So we store the data in arrays, we compress them, and we have a bunch of optimizations to allow us to scan these arrays as efficiently as possible. Basically, for example, by breaking them up, breaking the data, spreading it across nodes, breaking up the arrays into pieces, and farming out pieces of them to different cores on a single machine. So that's called vector-wise execution. These are things that allow it to run very fast and also scale to many petabytes. So everything we do is a column store. Those downward arrows mean that everything is a sequential operation. So we write sequentially, we read sequentially. And this is good. This was particularly important for rotating disk media. And it still is important because that is a very compact storage type. So we perform very well on that, but we also perform very, very well on SSDs. So that's ClickHouse. Just a little bit more about it. The optimizations for speed, if you want to know how it is that databases are made fast, what we do is we take the tables, we break them up into parts. We have, which are just chunks of data which we can then process in parallel. We index them. There's a little index that is very efficiently implements a primary key index. We sort the data so that it's basically coming out in a particular order already, and we have very efficient compression. And in fact, so that we're able to often get data down to, start at 100%. Through various compression techniques, we can get it down to less than 0.5% in many cases. So that allows us to be extremely fast and also not use a lot of storage. And then we also have sharding and replication built in. If you've used MySQL, that is not baked in. And so I actually ran a company for a number of years where one of the things we did was work with a lot of people who do that. It's a pain in the tail to do it. It's just better if it's built into the database. So my ClickHouse has both sharding, so those colored blocks like the red, the blue, and the orange, yellow, those represent different shards, and ClickHouse will allow you to, there's ways of loading. It also has built-in replication. And that's super nice because it means that you can set up a ClickHouse database and you can say, hey, I've got 3 shards, and by the way, I'd also like anything that hits this shard here should get replicated over there and vice versa. So this is all baked into the data warehouse. So it's a pretty capable database used by increasing number of people worldwide, all the way from like little teeny startups that maybe are throwing in just a couple 100 million rows, all the way up to people like Cloudflare. They ingest about 10 million, something like on the order of 10 million a second into a 100-node ClickHouse cluster. So that's ClickHouse. Let's talk about Kubernetes. So since most of you, this is kind of new technology. So some people pundits sometimes say, hey, it's the new Linux. And that's like, it says, okay, maybe I should read more. It's really a pretty empty statement. What Kubernetes does is it allows you to build systems on containers. How many people here have used Docker? Yes, Docker is great. One Docker is really good. 2 Dockers is still pretty good. 3, okay, it's starting to get difficult to manage. If you had 1,000 of them, that would be a serious problem. Kubernetes allows you to manage systems that consist of thousands of Docker images. So what it does is it manages the containers, and we'll see how it does that. It also allows you to do what's called declarative application definition. So you can say, let there be an application that has certain properties, like a certain number of containers, a certain amount of storage, and Kubernetes will just make it happen. It allocates the machine for resources to do that, and we'll talk more about that. And then it's also really easy to automate. So when you're operating at this kind of scale, it's very, very important to have things that allow you to run in using automated tools. So you can think of it as kind of the next generation of solutions after VMware. Has anybody here used VMware? Yeah, so some of you. So virtualization, it's kind of like the next step. How does it work? So here's a distributed service that might be a clustered database. It might not be, but let's say that it has 3 containers. Each of them has its own storage, which has to stick around. And the way that you might come into it is you might have a load balancer. So you just come in and you hit the load balancer and just picks one of these and you go there and do whatever operation you're doing. So this is a pretty common pattern. So Kubernetes is defining this using what are called resources. And some of the terms take a little bit of getting used to, but it basically is a way of saying, hey, I want an application that has these properties. So what that will reduce to is, let's start bottom up. We'll have what are called persistent volumes, and they are generated by what are called persistent volume claims. You tell Kubernetes, hey, I want 20 gigabytes of X type of storage. And that's called a claim. And if Kubernetes is correctly configured, it will go make that for you, and it will attach it to your pod. The next thing that they have are these things called pods. These are containers. They're like running Docker images. And then they are united. There's various ways you can do it, but a very common way when you're dealing with data is to use something called a stateful set. That is a collection of containers that have fixed names, so the names can be predicted. Moreover, they have storage that you'd like to have persist over time. So for example, if you restart the container, you don't want the storage to disappear. That would be bad. So this is the definition that you create. That gets you here's your computation defined here, here's your storage, and then the final thing is there's an entity called a resource called a service. That's how you get into it. So for example, that could be a load balancer, as we'll see just in a second. And then there's a couple other things. There are things called config maps. These are configuration parameters that you can feed into one or more of these pods. And then you have things called secrets. So for example, have you ever had to push certificates out to production systems? It's kind of a pain in the tail. So secrets allow you to have things like private keys stored in a relatively safe way and then passed into the pods when they start up. So it deals with, if you look at it, it deals with a lot of the issues you have when you're creating distributed systems. So what does that look like what'll happen is Kubernetes will just go map these to appropriate real things in the operating environment. So Kubernetes nodes, these are hosts or VMs. And that definition from the previous page might, not always, it depends on how Kubernetes is configured, but it might be an Nginx proxy at the front, which is then load balancing between 3 Docker containers, which have some amount of NVMe SSD storage. So that's what that definition we saw mapped. So this is what Kubernetes basically does. Take that definition, run it, and then Kubernetes will create this for you. So the problem that we were after was to have a data warehouse be defined in Kubernetes and then have Kubernetes set it up. And since our business is data warehouse and we want it to be as easy as possible, the problem is that real systems on particularly clustered data warehouses with replication, they are more complicated than that simple example that I just showed you. So a real data warehouse has a bunch of resources. It also has Zookeeper over on the side. That's a distributed directory service, if you will, that keeps track of data that needs to be kept consistent. But the problem that we have is this is so complex that if we just wrote all this stuff up, to define the resources individually, it would be really, really hard to do. There's just so much stuff, you'd end up writing a lot of complex code to implement this. And so what Kubernetes has introduced recently is something called an operator. And basically what it does is it allows you to define new kinds of resources. They're called custom resources. And they can just have a single file that defines them. And that file can have structure that is as simple or as complex as it needs to be. But the point is it's just one file. And it gets fed into what we call the ClickHouse Operator. That's a piece of software that we developed that runs in Kubernetes. And what it'll do is it'll read that file and it'll create all these resources on Kubernetes automatically and then tell Kubernetes to go make them. So what we're doing is basically one way that you can think of the operator working is it builds what you might call a best practice deployment of this data warehouse. This is a common way of explaining what they do. So this is what we set out to build. And so it took us, this is something that's available right now. In fact, it just got released it should be posting on what's called Operator Hub, which is maintained by Red Hat. That's going to be posting over the weekend, I hope. But basically, now to show you what these configuration files look like, they're really not that complicated. Let's check time here. All right, we're doing great for time. So here's an example. I want to make a warehouse. I want to make a data warehouse, and I'd like to have what I'll call a cluster. I'm going to call it replicated. So I can choose any name I want, but this is a good one because it really is replicated. And I'm going to say, hey, you can have 2 shards, and I'd like to replicate each of them twice. So 2 by 2. By the way, since we're it turns out for us, if you're running replication, you're going to need to have one of these Zookeeper applications. So we'll tell where Zookeeper is. And we just give a name. And Zookeeper is actually a Kubernetes application that looks almost exactly like that thing I just showed you a couple minutes ago, the simple one. So we just give the name of the load balancer. That's, in theory, all we need to do. Oh, and we have the name of our cluster, that's ch01. So we take that file, and we basically feed that to Kubernetes, and it will create a cluster. So it can be this simple. That's like a really big step forward. Now, it turns out that we would like to actually have a little bit more control than that. So one of the ways you get simplicity in these types of things is you usually have some form of templates in the background that say, hey, like what kind of storage do I want to have, and maybe how much. So for example, we have templates that you can add to this that will allow you to say, what does my storage look like? That's the volume claim stuff. What do my pods look like? Like what's the Docker container definitions? And how big are they? What image do they run? And the service template, which is how does the networking work? That's sometimes the most complex part. So here's an example of what we call the volume claim template. It's called persistent. We're going to use that. And it just says, hey, I want 10 gigs of storage. This is sort of, just saying, sort of a basic configuration parameter. There's more than this. Now, you can specify classes of storage if there are difference, but you can be as detailed as you want in here. And basically what this will do is then this information will be used to allocate the storage. And it follows, as it turns out, the same rules as Kubernetes uses itself in these things called volume claims. One thing that we learned, because we did learn a lot in this process and we're continuing to learn as we go along, is that if you mess this up, it can be really bad. I'll give you an example of that a bit, but you'll basically can end up with things not having persistent storage. That is unfortunate. So we'll talk about how we get around that. Templates themselves can actually be pretty simple, so they don't have to be hard. This one right here just says, hey, I want to have ClickHouse version 19.6, and it just gives the name of, that's the pod name, and then it basically just says, hey, where do I get this off Docker Hub? So the template is pretty simple, but they can also be very complex. This is an example where the pod templates are actually specifying a character called affinity. Does anybody know what affinity is? Like anti-affinity or affinity? Are you familiar with that concept? The notion is that if you have systems that are large and you want to keep them highly available, you don't want to put all your eggs in one basket. So if you have a bunch of shards, for example, you might say, hey, every shard should go on a separate physical host. So that's called anti-affinity, to push the shards apart. And basically this one right here is setting affinity to go ahead and push these nodes into the US East 1B Amazon region. So we can actually, there's a lot of flexibility in Kubernetes. We can say, hey, don't share them across single hosts, force them to be across different availability zones, things like that. So you can basically make this as complicated as you want. All of this stuff exists in Kubernetes. We just take advantage of it. And one of the reasons why this may seem kind of, if you haven't used Kubernetes before, this may seem like it's really complex, and you might ask, why would you want to do it? Well, it gives you a very, very important property, which means that I can start developing an application for a data warehouse, and I can run it on my laptop, or I can run it on a tiny Kubernetes cluster in my closet in my office, and I can scale that. I can take that definition, and I can basically, with a few tweaks, then push it out to have a multi-AZ deployment out in Amazon that might span 3 availability zones, might have 50 nodes in it, might be replicated 2, 3, 4 different ways. But you basically, with very, very small changes in these files, you can move between these Kubernetes environments and be able to have very, very different properties of the deployed system. But as a developer, as an app developer in particular, you don't have to know what the difference is. This portability is a really important property of Kubernetes. The other thing that it does is it gives you a lot of flexibility in saying, hey, what class of hardware do we want to use for particular deployments? So for example, by making a minor change in the deployment, I can switch, for example, from rotating disks or cheap desktop SSD to NVMe SSD out in the real deployment. So this is a very, very powerful way of putting these things together that doesn't require you to know a lot about what's going on underneath. And another cool thing that you can do is with this template approach, it's very simple to do operations like upgrade or to scale out. So I'll just give you a simple example here. I can add a new template, which is named after a new version, and I just say, this is my ClickHouse version, and that's where I find the container. I just go ahead and update the pod template, rerun this file, and it will just, like Kubernetes, will just go ahead and upgrade my cluster for me to a new version. So this is like by making literally, in the example I'll show you in a second, by literally making 5-character changes, I can force an upgrade across an entire cluster and do it safely as well. So this is pretty powerful. So let's see. Need my glasses. I've got a demo here, and I think we're doing well enough on time. Oh, here's the upgrade. Oh, so this is just what I said. It runs, reads that file, compares it to what's out there in the world in Kubernetes, and then goes ahead and upgrades the pods sequentially. Oh, one more slide. Monitoring. It's always good to monitor applications. So Kubernetes has a lot of really good monitoring built into it. There's a popular time series database called Prometheus, which you can install as a component in Kubernetes. In fact, the great thing about Kubernetes, among other things, is that you can just add new kinds of applications as you need them. There's another application called Grafana. You can that does the visualization, that reads from Prometheus, and then with a relatively small amount of deployment, you can build nice monitoring. So what I'm going to do right now is take a little teeny break, because I think we're good on time, and I'm going to just show you a quick demo of how this stuff works. So I'm out in Amazon. I'm pointing at a cluster that was created using something called cups. I'll just show you so here's the file. What I'm going to do is go ahead and create a cluster with 1 shard and 2 replicas. So I'm going to go ahead and run this file. So let's go ahead. There's a program called kubectl which applies these things. Okay, up it goes. All right, what's it doing out there? Well, we're going to actually run a command. Basically, what it'll show you is it's now beginning to create this cluster. Here's the stateful set, which we do something a little bit special. We have a separate stateful set for every node. That's a little bit unusual, but there's a load balancer interface, and it's actually going to resolve in DNS. This is something that happens automatically in this type of cluster. And then we have you can see the containers, which are up and running, and I can go and actually look at these containers. So let's go ahead, and I'm going to run an alias. I'm now connected to the container. I can do a very simple operation here. I'm going to add some data. Okay, I had created a table. And just prove it's there. It's called simple. All right, let's get out of this. Now if we look at the cluster, everything's up and running. I'm going to upgrade it. So this alias I'm running is just comparing the 2 files that I'm running. Here's the difference. That I ran this definition, this resource definition. I changed it from 19.6 to 19.11. And now I'm going to go ahead and apply it. Okay, it's applied. What's happening? Well, what's happening right now is that Kubernetes is going out and it's actually terminating the containers one after the other, bringing them up with the new version, and basically it's off and running. So this happens while everything is online. If I have apps running, they'll continue to work. I'm going to stop here. There's more to demo, but I think we're going to run short of time, and I want to have time for questions.
Actually, you have 5 more minutes if you want to run the demo.
Actually, I've got some more slides, so that's why I wanted to get back to that. Thank you. Oh, yeah. Do you mean just kubectl get pods?
Yeah, just pod status.
You mean like that? Yeah. And if I chose to add more replicas, I would get more pods created. If you're interested, I can run more stuff. It kind of goes on for a while. Let's just quickly then come back and summarize what we learned. Kubernetes is one. I think the first thing, and this is applicable for people in this room, you have to understand Kubernetes itself. So that's kind of a base assumption, but I think an increasing number of companies are doing that. If you do that and you start to move applications in, I think the single biggest issue that we found in making applications run is that DNS works really differently. And so applications often remember DNS translations in surprising places, like they tend to cache them because it's expensive to ask what's the name resolution. And so what'll happen is a pod restart will invalidate those caches, and then things will just stop working. That was a bug we had to deal with. Another one is that you get into these loops where hosts often want to resolve their name when they're coming up, but Kubernetes won't resolve the name for you until you're actually up, so it's kind of like a deadlock. Another thing we learned is that Kubernetes, this is a complex system, it's running containers, it's actually pretty fast. This is a sort of a toy comparison between roughly comparable Redshift and Kubernetes with ClickHouse. Deploy times are faster in Kubernetes. That we sort of expect because containers are quick to come up. Load about the same. Query performance about 10 to 1. That's typical, actually. So we see virtually no overhead from this system. Error handling can be complicated. That's something we're still working on. And I said that there was an example of what would happen with storage. If you screwed up storage. If you make an error in allocating storage, it could be that you use the wrong storage type or forget to allocate it entirely. In which case, Kubernetes will happily create your containers basically with your data out on temp. And so what happens is when the container restarts, it just disappears. And you won't find out until it's been running for a while, until a restart happens. So it's tricky to, you have to be aware of these cases. One of the ways we're addressing this is by providing global templates which will make the pods by default do the right thing. So that's one of the ways you solve this. So there's definitely some challenges. I think the big thing that when you move any data to containers, not just Kubernetes, but containers in general, is that data warehouse is not cattle. The cattle versus pets. How many people have heard cattle versus pets? Okay, so the idea is data warehouses are typically pets. If you lose them, you feel really sad. So, well, that's how I feel about my cats. So you have to be safe, and Kubernetes doesn't give you everything that's necessary to do that. So you actually have to build stuff on top of it. The good news, though, is with Kubernetes and this operator that we've developed and other operators that are emerging, any application can have a data warehouse. And this is really important because we actually foresee a world. I mean, everybody is here because they deal with data. We foresee a world where the volumes of data are going to require millions of data warehouses. And I don't say this lightly because this kind of transition has happened before, but if you just run the numbers, think about automobiles, 18 million of them produced in the United States yearly. They generate enough data, they generate levels of data now that will saturate data warehouses of 20 years ago, or databases of 20 years ago. We're going to see data warehouses in all kinds of places. And Kubernetes is one of the ways to get this. So just wrap up. So this operator, if you'd like to get started on Kubernetes, I just started this job on January 1st on working at this company. The way I actually learned about the data warehouse was I ran the Kubernetes operator, and it set stuff up for me, and then I could go look at it to see what it did and understand how the data warehouse worked. So it's a very convenient way of doing it. It also validates many of the values that we had. Oops. But we know that it's not, for all use cases, it doesn't cover all the use cases, so we need to build stuff on top of it to use it effectively. One thing about Kubernetes, if you do get a Kubernetes enthusiast, having everybody just run in and set stuff up by themselves on Kubernetes is going to lead to really bad experiences. So you need to have structure on top of it that sets rules and policies. So that's actually what we're working on, is we're building data warehouse as a service. We're going to use Kubernetes. We are this is probably like the least original idea in this field at the moment, but it handles things from multi-tenancy down to resource utilization. And we're also working on the data warehouse itself to make it work better with this cloud native model. And one example is being able to rebalance data. It's very easy in Kubernetes to balance things up and down. So make the data warehouse move the data back and forth. So that's an example of work that we're continuing on. And that's actually the end of the talk, and this would not be a real talk if I didn't say we're hiring. So we're projecting 3x organic revenue growth is something like 3x this year. We're going for funding, and if you're looking for an adventure on data, we got one for you. So thank you very much.
Thank you.
And I think we have some question time.
Do we have enough time? If you guys want to ask any questions, please go ahead.
I have a question.
Yes, please.
To get any pushback on implementing Kubernetes or containers in your line of work?
Well, see, okay, so we're supplying this to people that are, to our customers, and no, in fact, it was pull. It was people saying, hey, we're on Kubernetes. So what's happening is we have, there's one of our customers runs possibly the largest content delivery network in the world for software, and they use Kubernetes, they use this ClickHouse data warehouse to do all their analytics on the content delivery, and they run it on Kubernetes already. So they had already, a number of the companies had jumped on it and were already going there. So this is actually, and financial services, for example, it's very popular as well. It's a really good way to deploy applications quickly and to operate them efficiently. So yeah, we've definitely had a lot of, yeah. Yes?
I have a question about cost, some
Yeah.
data. With all of the scaling, so how does it impact costs for data warehouse?
That's a really interesting question. So actually, I was worried about time, so I flashed the slide. One of the things that I think is important is ultimately, well, first of all, you've got to realize that some of the way that this problem is going to get solved is the data is never going to make it up to the cloud. It's actually going to be processed locally. So, for example, on the car, and so the volume of storage that you need is in the level of terabytes, which can be handled by single devices. But more generally, the other thing that we're working on is to decouple compute and storage. So, for example, have tiered storage, so that as you're, like if you have marketing data, the stuff from yesterday is really important, the stuff from last week is less important, and the stuff from last year you couldn't care less about unless the SEC is after you. So you do tiered storage and basically move it, between different levels of storage and ending up in, exactly, warm, cold, frozen kind of thing. So that decoupling is really important.
You keep referring to cars. Does that mean that a container is running locally to the car?
In automobiles, yeah. We already know that Yandex actually had this. So, for example, if you look at self-driving cars, the amount of test data they generate, it's on the order of, I think, petabytes. It's a staggering amount of data.
Especially when they start marrying sensors.
Yeah. So, and the thing that's happening here is, so everybody talks about how data is growing, but it's not all going to grow in Amazon. It's coming from devices, and you do the math. That data, it's going to continue to, it's exploding all over the place. People are going to have to process it and act on it locally. You can't push all this data up into the cloud.
So
Yeah.
what you're suggesting is that edge computing is going to evolve into some sort of a container environment?
I think this is a very likely way that edge computing will be done, because it's very simple to do service architectures in it. So you think, hey, I need to go out and I need to run a car. What's my application deployment model? Kubernetes is actually a really good solution for this. We don't know for sure that this is going to happen, but the math on the generation of data makes it clear that data warehouses and streaming processing, things like Kafka, predictive analytics, are going to end up in these edge computing environments to allow people to process data. Does that mean I'm done?
No, that means we have 4 minutes.
We are 4 minutes, so that means we have.
Any additional questions?
Yeah.
Do you have a shard, the size limitation? Because when you define a shard, the database
Size of your storage. Yeah, size of storage volumes. So shards are limited by the size of storage.
Like I have 1 terabyte storage, it's defined a shard.
Yes, exactly. In fact, that's a problem we're fixing by allowing it to move to multiple volumes and then persist eventually to deep storage, to object storage.
Okay.
So we can break.
You have both primary replication same time during the loading.
I think I didn't understand the question.
And so my confused, if you have a replication during the loading, it will be slowed down?
Oh no, it's asynchronous.
Or synchronous?
Yeah. Yeah, in fact, I can talk about if you want to learn about the loading, I'd be happy to. You had a question, I think.
Yeah, I was just curious if this is like suitable for like spinning stuff up and then spinning stuff back down. Like,
Yes.
Quickly.
Yes, yeah. In fact, this is where it really shines. And there's 2 ways that this can be used. One is you have like bursting type things where you got a problem and you need to spin something up fast. The other thing is you think about how you do development, it's all about cycle time, right? I mean, nobody writes anything that's perfect. What you do is you spin something up, load data into it, check out performance, and then throw it away. You do this, in fact, if you have build pipelines, you're doing this like potentially dozens or even hundreds of times a day. It's ideal for this.
Yeah, like, can I give an example?
Yes.
We have some services that are like hammering our data warehouse
Yes.
daily or whatever it is, and they're getting in the way of like the analytics activity.
Right.
And I'm wondering if we could like know that this thing is going to spin out and just give it its own.
You give it this is what you would do is you would actually, so what this can now do is, and if I understand you correctly, one of the things you can do is you now have the ability to create not one but many data warehouses. And so you give that application, that's an example of where the application needs its own data warehouse so it doesn't mess with the other applications. Yes?
You had an example on one of your slides where you were comparing Kubernetes query performance versus Redshift.
Yes.
And there were some dramatic speed differences
Yes.
between the 2 environments. Could you expand upon that a little bit?
We're really fast. ClickHouse is really fast. It's the fastest. There's the billion taxi rides. If you go look at the billion taxi rides, billion taxi rides benchmarks. If you just Google that, we're typically as fast as anybody with it who doesn't use GPUs.
And that's primarily coming from concurrency.
Concurrency and very, very good compression, very good optimization, very good. Redshift is kind of crappy technology. It is a beautiful product. It was an absolutely groundbreaking product, but the data warehouse underneath it is not super fast. So this one is much faster. On the other hand, of course, it's up in Amazon. It's very well managed, very easy to.
That reference again,
Billion taxi rides benchmark by Mark Litwinchik. I wouldn't Google that. So I think we're probably done. Is that? Thank you.
Actually, you have 1 more minute.
I have 1 more minute. 1 more question? Yes, please.
Can you talk a little bit on the Kubernetes hybrid implementation, like some on-prem and some on cloud, orchestrated?
Sure. Yeah, that's actually a really interesting question. So the first thing in hybrid, hybrid has a couple different meanings. One definition of hybrid is we run in both places, but we only run in one at once. And this demo I showed you illustrates that because I actually developed that configuration file on Minikube, which is like a desktop version of Kubernetes that you use for development, running in my closet. And then I set up this cluster in Kubernetes and I just ran it without changes. So you have portability. So that it solves that problem. And that has a big impact for businesses because it means that you can choose where to run things based on the economics or things like geographic location, all that sort of stuff. What we don't run, Kubernetes typically does not run across, like to run 2 different Kubernetes distributions. You could do it. I haven't actually done it myself. It will definitely run. I think the big thing you don't want to do is you probably don't want to have Kubernetes running across regions, because the real limitation with Kubernetes is it needs to have relatively low latency networking between all parts of the cluster, like sort of, within 100 miles, something like that. So that probably, I would use separate clusters, and then there's ways of setting up the data warehouse to operate over distance.
All set.
Thank you so much. Thank you very much.